Good morning, learners. We are going to start today with what we call a quadratic sequence. This is a revision of something that is going to come out in the exams. And let's understand what do we talk about if we talk about the quadratic sequence. Now, in a quadratic sequence, what is important is that the second difference is constant. Second difference is constant. The second difference is constant, right? And then the general equation for this quadratic sequence is as follows. The general equation is for the nth term, or the general term is Tn, which is equal to an squared plus bn plus c. This equation is very, very important as far as the quadratic sequence is concerned. Now, A, B, and C are constants. A, B, and C are constants. Now, N stands for the position of the term in a sequence. Once more, N stands for the position of the term in a sequence. That is, i.e., term number 1, term number 2, and so on. Right? And then, now, let me just come to the A, which is also very, very important in this sequence. Remember that I said in a quadratic sequence, the most important formula or equation that we have is Tn, which is equals to an squared plus bn plus c. Now, let's understand the meaning of this constant A. Now, A is a constant term, as I said. A is a constant term, as I said. And then this A is equal to, it is equal to half of the second difference. Second difference. Very important. I'm going to explain it again. As I said before, A is constant and it is equals to half of the second difference. I will come to this second difference as we go on. And then also B and C are constant terms. B and C are constant terms. Right. Now, let us go to the example of this quadratic sequence. Now, here I'm having something like this example here where it says determine or find. Determine or find an algebraic expression. An algebraic expression for the nth term. The nth term that represents the sequence the sequence 4, 7, 14, 25, and so on, or up to infinity. In other words, what we are given here, we are given the sequence 4, 7, 14, 25 up to infinity. Now, we must get the what? The nth term or the general term. Now, in this case, you must ensure, or you must make sure, you must ensure that the sequence is quadratic. You must ensure that the sequence is quadratic. Now, what you are given, the first term of the sequence is 4, the second term is 7, the third term is 14, and another one is 25, and they move on up to infinity. Now, the first difference between 4 and 7 is going to be 3, and the difference between 7 and 14 is going to be 7. The difference between 14 and 25 is going to be 11. And this is going to be what we call the first difference. This is the first difference. Now, can we go over to the second difference? Now, the second difference here is 4, I can see, because 7 subtract 3 is 4, and 11 subtract 7 is 4. Therefore, this is going to be the second difference. Then we can talk again that this sequence is quadratic. Remember that I said the formula that we use for the quadratic sequence is Tn is equals to an squared plus bn plus c. That is the formula that we use. Now, here we are having that 4, 7, 14, 25 up to infinity is our sequence. Now, we must determine the what? The nth term. Now, how do we go about determining the nth term? We must ensure that the sequence is quadratic. How do we ensure? We look for the first difference and the second difference. As I said, the 4, 7, 14, and 25 are the numbers of the sequence. So the first difference is 3 between 4 and 7. And then between 14 and 7 it's 7. Between 25 and 14 it's 11. This is the first difference. And then the second difference between 3 and 7 is 4. 7 and 11 is 4. Therefore, the second difference is 4, which is constant. It is not changing. Right? Now, therefore, it means that the formula Tn, which is equals to an squared plus bn plus c, holds if you want to use it. Now, we go back to our constants. I said a, b, and c are our constants. Now, a, as I said, is a constant term that is equals to half of the second difference. And then obviously b and c are also constant terms. Now, let's see from here, how do we go about? Now, we start first by calculating the value of a. Now, what did we say? We have said that a is half of the constant difference. In other words, 2a is going to be equals to 4 because a is the first term. So when we multiply 2 by a, we must get the constant difference. And then surely a is going to be equal to 2. A is equals to 2. Now, in the equation, since we have a to be equal to 2, then Tn will be equal to 2n squared plus bn plus C. Now, it will be easy for us to get what? B and C. Now, 4 is the first term. Now, if 4 is the first term, what is going to happen here? We are going to say 4 will be equal to, because 4 is the first term, 2 into 1, because n stands like when I said there, the position of the term in the sequence, whether it's the first term or the second term or another terms. Therefore, 4 will be equal to 2 into 1 plus B into 1 plus C. In other words, we are able to get the values of B and C by using what we call simultaneous equations. Therefore, here 4 is going to be equals to 2 plus B plus C. And then ultimately, 2 will be equal to B plus C. Now, this is an equation that is having what? B and C. In other words, we are able to solve for B and C. Remember, I used 4 as the first term, so n is going to be equal to 1. Where there is n, also there is going to be 1. And ultimately, this thing is going to be 4 plus 2 is equals to 2 plus B plus C. And then ultimately, this is going to be equals to 2 is equals to B plus C. That is going to be our first equation. Now let's go to the second equation that is going to involve B and C. Now 7 is the second term. Therefore, we are going to say that 7 will be equal to 2 into, because 7 is term number 2, we are going to substitute n by 2. And then here, it must be n squared. Remember, it must be n squared. Therefore, this is going to be 2 to the power 2. Right? And then this is going to be plus 2 into 2. Not 2, B, because we are aiming for B and C. Therefore, this is going to be 7 is equals to 2 into 2 squared plus B times 2, because the number of 7 is 2, and then plus C. Now this thing is going to be 7, which is equals to 8 plus what? 2B plus C. And then ultimately this is going to be equal to -1, which is equals to 2B plus C. That is going to be our second equation that is involving B and C. Now, it's easy for us to solve for B and C. Now, let's see, how do we go about? We have said that the first equation was, let me just write it down here. The first equation was 2 is equals to B plus C. And then the second equation is -1 into 2B plus C. All right. Now let's see how do we go about solving there. Now, this is going to be, if I say I'm having a first equation subtracting second equation, then this is going to be like this. This is going to be like this. It is going to be C subtract C is a 0. So we will be eliminating C. And then this is going to be 2 subtracting this. The answer is going to be 3. And then B subtracting 2B. the answer is going to be minus b. Therefore, b is going to be equals to negative 3. b is equals to negative 3. So we have already got the value of a, we have got the value of b. Then it is easy for us to get the value of c. Now, let me see how are we going to get the value of c. The value of c is going to be like this. The value of c, since b is negative 3, is going to be, if we have b plus c, which is equals to 2, and minus 1 is equals to 2b plus c, then it is easy, as I'm saying, for us to get the value of c. Now the c, we are going to get it by substitution. By substitution. Now let's see in the original equation. In the original equation, we had Tn, which is equals to an squared plus bn plus c. We had here, let me see, the first term was 4. Now let's see if the first term is 4. It will be 4 into 2 plus 2 into 1 all squared plus b. b is what? We have said that b is negative 3. And then what else? n is 1. And then c is the one that we are to get. Let me see. This is going to be 4 into 2 minus 3 plus c. And then this is going to be 4 is equals to 2 minus 3 is minus 1 plus c. Obviously, then c will be equal to 5. Now, if c is equals to 5, let's see the equation. The equation will be Tn into a is 2. A is 2, let's see, 2n squared minus 3n plus 5. That is going to be our equation. I'm just going to take an exercise from the book here that you must do as an exercise. I'm just going to give you, say, 4 minutes for this exercise. Let me write it down here. Let me write it down here. Let me write it down here. It says, consider the sequence 8, 18, 30, 44, up to infinity. And then the question says, write down the next two terms of the sequence. If the pattern continues, in the same way, and then that is going to be 2 marks for that. And then another one, let me say this is 1, another one is 2 here. Then this is where you calculate the nth term of the sequence. And then you get how many marks? 6 marks. And then number 3, which term of the sequence is 330. And then you get 4 marks. Alright. Now for this, I'm just going to give you plus minus 4 to 5 minutes. Thank you. Okay. Okay, folks, let's go to our exercise. Now, points to remember when you are to do this exercise is this. I said, since we are dealing with a quadratic sequence, what is important is that the second difference is constant. And the general equation for the nth term is Tn, which is equals to an squared plus bn plus c. Now, very important, n is telling us about the position of every term or any term in a sequence, whether it is term number 1, term number 2, term number 3, and so on. And when it comes to the a, it is a constant which is equals to half, let me underline it, half the second difference. In other words, if it goes to the second difference, it is your duty to get the first difference and then establish again whether this sequence after the second difference is quadratic or not. Now, obviously I said B and C are constant terms. Now, this is the basic of what is important about the quadratic sequence. All right. Now, let's go to the exercise now. Let's go to the exercise. Let's go to the exercise. Right? Now, how are you going to get because the question there said, write down the next 2 terms of the sequence if the pattern continues in the same way. Remember that this you are going to get, it's 2 marks, it's easy, I understand. But you are going to make sure when you test whether the sequence is quadratic or not. Okay, now let's go to the solution. Let's go to the solution. We had 8, 18, 30, 44, up to infinity. Okay? Now, here, let's get the first difference. The first difference between 8 and 18 is 10. The second difference, the difference between 18 and 30 here is 12. Right? Another one here is 14. Therefore, we see that this is the first difference. Right? Now, if it be the first difference, we go on. We go on to the second difference. The second difference is going to be 2 here. The second difference here is going to be 2. Therefore, this is the second difference. Now, this second difference is constant. It is constant. Now, it will be easy for us to get the remaining, the other 2 terms. The next term here, it is going to be what? 60. Another term is going to be 78. And then you get your 2 marks. Right. Let's go again to the second part of the exercise. It says calculate the nth term of the sequence. Now, here, very important, very important, very important. We have said that A times 2 is equal to the second difference. Now, A is going to be equal to 1. And then, the general term is going to be equal to n squared plus bn plus c. Why? Because the value of A is 1. We have calculated it. Now, 8. Remember, 8 is the first term. It will be 1 plus b plus c. Right? And then, therefore, from this, it simply means that 7 is going to be equal to b plus c. And that is going to be our first equation that is involving what? B and c. Now, again, 18 is going to be equal to 4 plus 2b plus c. Remember that 18 is the what? Is the second term or term number 2. That is why now here we are going to have 18, which is equals to 4 plus 2b plus c. And then ultimately 14 is going to be equal to 2b plus c. And this is going to be our second equation that is involving b and c. And then equation number 2, subtract equation number 1. Then we are going to have 14bc. 14 is equal to 14 is equals to 2bc, 2b plus c rather, and then 7, which is equal to b plus c. What did we say? It must be the second one subtracting the first one. And the answer there is going to tell us that b is going to be equal to 7. Right? And ultimately c is going to be equal to a 0. Therefore, what is happening there is going to be Tn is going to be equal to n squared plus 7n. Now let's see how the marks are being allocated. How the marks are being allocated. Very important. A is equals to 1. For getting the value of A, you get 1 mark. Right? And then for the substitution of A, you are going to get 1 mark. And then solving the simultaneous equation here, you are going to get a mark. And then the value of B, a mark. The value of C, a mark. And then the general term also is going to be a mark. Right? Now this is going to count 6 marks. Very important. As I'm saying again, I said when we started, I said the general term must be in the form Tn is equals to an squared plus bn plus c. So you will be required to calculate the value of A, the value of B, the value of C. Right. And for you to get the values of B and C, you are going to use simultaneous equation. The simultaneous equation. Right. Let's go to the solution for the other one. The solution for the other one. Right. The other one is this one here. The other one is this one here, where we are to get, let me see, which term of the sequence is 330. Which term of the sequence is 330. Now, this one is going to be like this. This one is going to be like this. It was the third one. It was the third one. Let's see how do we go to the third one. Now, the third one is quite easy also. Let's see how do we do it. The third one is this one. N into n plus 7 is equal to 330. Right? Therefore, n squared plus 7n minus 330, the answer is equals to a 0. And then, if we factorize this expression, the answer is going to be n plus 22 into n minus 15, which is equals to 0. Therefore, n is equal to negative 22, or n is equals to 15. Therefore, n is equals to 15. Therefore, 330 is the 15th term. Now let's see how the marks are going. You get 4 marks. Okay? You get 4 marks for substitution. Right? You have substituted. And then you go to the standard form. The standard form. And then factorization. And then for the answer. That counts 4 marks. That is, in short, all that was necessary for the quadratic sequence. Now, from the quadratic sequence, I must also discuss the sequences and series. Right. Now, in the issue of sequences and series, what is important is the formulae that are involved in sequences and series. I'm just going to give you the formulas that are very important in sequences and series. I'm going to give you a summary of this formulae. Now, arithmetic sequence. We are going to have the equation for the general term to be a Tn is equals to a plus n minus 1 d. And then for something geometric, we are going to have Tn is equals to AR n minus 1. Right? I am saying we are going to do sequences and series. Now, our sequence can be arithmetic or it can be geometric. Now, this is the formula that is basically used in the arithmetic sequence. The general term of the arithmetic sequence, T subscript n is equals to A plus n minus 1 into D. In other words, for you to get the general term or the nth term, you must have the value of A, the value of N, and the value of D. Now, the geometric sequence, the general term or the nth term, you must have the value of A, the common ratio, and then the number of the term also is very, very important. Right? Those two are important in sequences. Right? Now, let's go to the series. Now, Sn is equals to n into A plus L all over 2 if you know the last term. And then Sn for something arithmetic also is equals to n over 2 into twice A plus n minus 1 D. Right? When the last term is not known. That is for something arithmetic also. In other words, these two are for something that is arithmetic. Right? Now, the series, if it is geometric, what are we going to have? We are going to have Sn, which is equals to A into r to the power of n minus 1 all over r minus 1 when r is greater than 1. Very important. Very important. And then it is going to be Sn is equals to A into 1 minus r to the power of n over 1 minus r when r is less than 1. Very important. Now, as I said, in sequences and series, there are formulae that are very, very important. For arithmetic sequence, we are going to have Tn is equals to A plus n minus 1 into D. In other words, if you are to get the nth term or the general term, you must have the value of A, the value of n, and the value of D. Now, in a geometric sequence, the nth term is given by A r to the power n minus 1. Right? Now, in series, the formulae are as follows. Sn is equals to A into A plus L over 2 when the last term is known. And then Sn is n over 2 is equals to n over 2 into 2A plus into n minus 1 times D when the last term is not known. Now, something geometric in the case of series, Sn is equals to A into r to the power n minus 1 all over r minus 1 where r is greater than 1. Right? Now, Sn is equals to A into 1 minus r to the power of n all over 1 minus r when r is less than 1. Now, I'm just going to have some examples on these sequences and series that we must know. Right? Now, here, let's look at this. My example is, consider the sequence that is given here. Half, 4, 1 over 4, 7, 1 over 8, 10, up to infinity. Now, it is said that if the pattern continues in the same way, write down the next two terms in the sequence, and then it has 2 marks. And then the second point is this one. Calculate the sum of the first 50 terms of the sequence, and then it has 7 marks. Now I want us to check this sums that we are to do. Right? Now, let's analyze this thing. Here we are given a sequence. A sequence has the terms half, 4, 1 over 4, 7, 1 over 8, 10. Now, they say, if the pattern continues in the same way, write down the next 2 terms of the sequence. All right. Now let's go to the solution. Let's go to the solution. When we look here, the sequence has these numbers. The first fraction was 1 over 2. The second fraction was 1 over 4. The third fraction was 1 over 8. In other words, when we look at the fractions, the denominator has been multiplied by 2 to get a 4. The denominator has been multiplied by 2 to get an 8. Obviously, the next one, 1 over 8, the denominator will be multiplied by 2. And then this is going to be 8 times 2. And obviously, this is going, the next one is going to be 1 over 16. Now, when we look at the whole numbers, 4, 7, 10, they differ by 3. Now, if they differ by 3, then 10 plus 3 is going to give us 13. So, the next 2 terms are going to be 1 over 16 and 13. And for this, you get your 2 marks. Now, let's sort out number 2, where we are to calculate the sum of the first 50 terms of the sequence after break. Thank you.